Determine the t-value in each of the cases. So first we want to find the t-value such that the area in the right tail is 0.005 with 5 degrees of freedom. So we're going to do a stat crunch, click on Stat, Calculators, and then we're going to go down to T. So this is a little bit different. We have degrees of freedom here. And so degrees of freedom is just our sample size n, lowercase n, minus 1. And a t distribution is very similar to a normal distribution. So you'll notice that in the middle, our mean is still 0. And it varies based on different standard deviations. So it's based on a sample, and we don't know the population, and it's called a student's t-distribution. And the reason it has that name is the guy that created it worked for a company, and they didn't want to have anything associated with that. Wanted it to be secret and all of that. And there's a nice little blurb in your book about it, but so it isn't normal, but it approaches a normal distribution the larger our degrees of freedom are. So the larger n is, the closer it is to the normal distribution. So that's a little bit about it. Has still symmetric about the mean. So the properties are in the PowerPoint, so you can read through those. So we're going to type these in here. So we have 5 degrees of freedom. And with the area in the right tail, so we need to make this greater than or equal to. And our area here is 0.005. And I'm going to snip this here. Oops, what happened? Copy, paste. Probably underneath this here. So we're going to have that there, and we're going to hit compute, and that'll give us the t value there. Let's pull this up and do a little screen capture here. Let's see what that looks like. That's how I initially put that in there. Now we're doing T calculator, so I'm going to copy this over so we can see what we did there. So our answer here is 4.02. So typically round those to 3 decimal places with t values. So now we want to look at the right tail again, and we want that to be 0.01, and we have 16 degrees of freedom. So I'm going to hit compute there. So this one is 2.583. We want to find the one with the area to the left, so the difference there is 0.15, and we have 17 degrees of freedom. So this is 0.15, 17 degrees of freedom, and we have the area to the left. So I'm going to type that there. So our t-value here is negative 1.069. So notice this one's negative, which makes sense. So 0 falls in the middle, that's our mean. Anything to the left would be negative, anything to the right would be positive. So one more of these. We're going to find the critical value that corresponds to the 96% confidence with 8 degrees of freedom. So we're going to come over here to between. Our degrees of freedom is 8, and 96% confidence. We're using the critical values, so this is t sub alpha over 2. So we're going to use the positive one, so this is 2.449. So that's how we would find our t values.